Welcome to my video. This is the presentation about Riset Operasi. My name is Cahya Rizkia from Kelas RegB 5C. And now I will explain material with the title Integer Linear Programming. Integer linear programming. An integer linear program (ILVS) is a linear program in which some or all of the variables are limited to integer or discrete values. When you study ILV, you need to concentrate on three areas: application, theory, and computing. In this chapter, there are three discussions: a number of applications that demonstrate the rich use of ILV in practice, present to algorithms, and problems that have important practical application. 1. Illustrative application. The second, present a number of ILV application. Application generally fall into two categories: direct and changeable. In the direct category, variable are natural integer and can use some binary 0 or 1 or common discrete values. For example, the problem may involve determining whether a project is selection for executive binary or not. In the modified category, the original problem, which may not include integer variable, is analytically difficult to solve. An auxiliary integer variable, usually binary, is used to make it sortable. For example, inserting two jobs A and B on one machine, job A can coincide job B, or job B can coincide job A. It is the natural of the OR constraint that makes the problem difficult to solve analytically, because all mathematical problem programming algorithms only dealing with the AND constraint. This situation is corrected by use a number binary variable to convert the OR constraint to an equivalent AND constraint. For executive, a pure integer problem is defined to have an integral variable. Otherwise, the problem is a micro-integer program if it deals with continuous and integer variables. 2. Capital budgeting. The second deals with decision regarding whether or not investment should be made in individual projects. Decisions are made based on constraint of the limited budget as used as priorities in project implementation. 3. Set covering problem. This is overlapping service operated by a number of installations to a number of facilities. The aim is to determine the minimum number of installations that will cover with the service requirement of each facility. For example, water treatment plants can be constructed in multiple locations, with each installation serving a defined set of cities. Overlap areas when a particular city and receive the service of more than one factory. 4. Fixed change problem. The problem of fixed cost relates to situation in which economic activity includes two types of costs: initial flat costs that must be incurred to start the activity and variable costs that are directly proportional to the level of activity. For example, starting a machine to before starting production requires fixed settings depending on how many units are produced. After the setup is complete, the labor and material costs are proportional to the quantity product. And last, either or and if-then constraints. In this second, we deal with models in which the constraints are not satisfied simultaneously, either or defined in if-then. The transformation does not change the or dependency properties of the constraint. The transformation just uses a mathematical trick to present it in the described and constraint format.
Thanks for your attention. Bye bye.